Hi everyone. So the first lecture will be about quadratic equations and introduction. So first of all, it's a quadratic equation, so equal to sign should be there. So many people think like this is the quadratic equation. So first get your fundamentals clear. It has to be like equal to 0. And what is a quadratic function? If f of x equal to ax square plus bx plus c, this is a quadratic function. And this particular thing is a quadratic equation when you equate something to 0. So any equation in which the highest degree of the polynomial is 2, then you can say it is a quadratic equation. And there is one more condition: your coefficient of the highest degree, which is 2, should not be equal to 0. So ax square plus bx plus c equal to 0, in which a should never be equal to 0, you call this as a quadratic equation. So few things about quadratic equations, like what are the roots of quadratic equation. But before diving into roots, we should understand like this particular thing is nothing but a parabola. So imagine something like this. So a quadratic equation, if you plot a graph on x and y axis, there can be many cases, right? Now let us assume one particular case where this particular graph cuts our x-axis at two particular places. Let us call this first place as alpha and the second place as beta. So we can say that whenever the value of x will be equal to alpha, the function value or the quadratic equation value will be 0. So here f of alpha equal to 0. Here you can say f of beta equal to 0. So you can say alpha and beta are the roots of this particular quadratic equation. Why? Because at x equal to alpha and beta respectively, you will get this quadratic equation coming out to be 0, because the function is itself 0 over here. So you can represent this particular equation as x square minus alpha plus beta times x plus alpha beta equal to 0. So this particular equation will have the roots as alpha and beta. And you can prove this like this also. Suppose you have an equation x square minus 5x plus 6, right? So can I write it as x square minus 3x minus 2x plus 6? Can I write it as x into x minus 3 minus 2, x minus 3, x minus 2 times x minus 3. So if it is equal to 0, this has to be equal to 0. So this particular equation is 0. Either x equal to 2, then it will be 0, or x equal to 3, that will be 0. This means at x equal to 2 and at x equal to 3, this particular graph is cutting like this. So this is f of x, or you can say this is my function, quadratic function, x square minus 5x plus 6. And you can see one simple property, that the term which has no coefficient of x, or where x the coefficient of x is something and power of x is 0 over here, this particular thing is known as product of the two roots. So as I have already mentioned, is x square minus alpha plus beta times x plus alpha beta. So in ax square plus bx plus c, if you are given this quadratic equation, then you can say minus b upon a is your sum of roots alpha and beta, and c upon a will be product of roots alpha beta. So this is nothing but the Vieta formula. So this is a basic thing you should know about quadratic equations. Next we move to nature of roots. So this is a very important topic in quadratic equation. So to know the nature of roots of the quadratic equation ax square plus bx plus c equal to 0, you should ask yourself what is the discriminant. So but before that, you should know what is like how to reach to that particular discriminant. So what is discriminant, we'll talk about that. But first so in the case of x square minus 5x plus 6, we got to know that it is x minus 2 into x minus 3. So somehow we need to convert this particular type of equation into this type of multiple. So how can we do that? So first we need to find what is x. So in order to do that, we can try to complete the square over here. So suppose it is x square plus, divide the whole equation by a, x square plus b over a x plus c over a equal to 0. So you can treat it like 2 times b over 2a times x plus c over a. Now if I need to complete the square, we know that a plus b whole square is equal to a square plus b square plus 2ab, right? So suppose this is my a and this is my a, this is my b, so this is a square, so I have to add something like b square, so it is b, so I will simply add over here plus b over 2a whole square, and if I'm adding I'll have to subtract also, because in order to make it equal. So this particular thing over here, x square plus 2 times b over 2x plus b plus 2a whole square, this is my sorry, not this, actually we'll have to club it like that, minus and then plus. Why? I will tell you, because I need to find the roots. So this will be x minus b by 2a whole square plus b square by 4a square minus, sorry, plus c by a. So this is my quadratic equation, so equal to 0. So you can clearly see I can calculate the value of x. How? I can do it like this, x minus b over 2a whole square. Oh no, one thing, I'll have to do like this only. Here it will be plus and here it will be minus, and here it will be plus over here only. So, and this will become minus b square by 4a. Yeah, now this is correct. So x plus b over 2a whole square is equal to b square by 4a square minus c by a. And because this is a square, if I take under root, this means b square by 4a square has to be greater than c over a. Okay, this is one condition. So if I take a square root on both sides, I'll get x plus b over 2a equal to square root of b square by 4a square minus c over a. Okay, and if I put it like this, minus b over 2a, because I need to find what is x, I'll have to do like this, minus b over 2a plus minus, because a square root is always like the value is always 2 times, like plus or minus, because if you square you'll get this only. So plus minus under root. Now if you take 4a square as common in denominator, it will be like 4a square. So this will be b square and this will be 4ac. So this will become minus b over 2a. Now this is 4a square, this will come out neatly, plus minus 2a, this will be 2a over under root of b square minus 4ac. So this will be minus b plus minus under root b square minus 4ac upon 2a. So this will be the value of x. So that is how, using completing the square root, you get to the value of x. So this I derived in front of your eyes. So once you get this, x is equal to minus b plus minus under root b square minus 4ac upon 2a, this particular value sitting over here is d. So discriminant is nothing but under root of b square minus 4ac. Sorry, b square minus 4ac. So you can write it at x is equal to minus b plus minus root d over 2a. So this particular discriminant is very important. Why? Because in order for your x to be real, in order to your quadratic equation or your parabola to get some real roots, to cut it over here, it has to have this particular square root over d has to be greater than 0. It has to exist. It should not be imaginary. That means there is a condition. We will get real roots if and only if your discriminant is greater than or equal to 0. Why? Because otherwise it would be imaginary, because you don't know whether this exists or not. Because if it is cutting over here, this means x has two different values, minus b minus under root d over 2a and minus b plus. Alpha will be minus b minus under root d over 2a and beta equal to minus b plus under root d over 2a. So this is your alpha and this is your beta. Okay, so that is the thing. So we were on like nature of roots. So let me discuss now the nature of roots. So this is very important, so kindly pay attention. So here d is greater than or equal to 0. We're not talking about a right now. A is the coefficient of x square. So what if your graph is like this? If your graph is like this, it is touching at only one point. This is your alpha. If it is touching at only one point, this means x is equal to minus b plus minus under root d over 2a. This means your quadratic equation or quadratic function is x minus a whole square. It is a perfect square. You can write it like this: x minus alpha whole square. So if you expand it, it will be x square plus alpha square minus 2x alpha. Okay, so it will be something kind of like this, where it cuts only at one point. So you can say it is a perfect square, right? So it can only happen when your root d is a perfect square. So there are other ways to look at it also. So if you want your nature of roots to be imaginary, this means your square root of d has to be less than 0. Okay, your d has to be less than 0. If your d is less than 0, that means it will be imaginary and it will be no real roots. So in case of no real roots, your graph should look like this. Either this, no, it cannot look like this because again it will cut. So since the graph is always above, it will never touch your x-axis. So this is d greater than 0, and you'll notice one more thing. At any point, if you calculate your f of x at any point, that means the values, it will be always greater than equal to 0. Greater than 0. F of x is greater than 0 for all x. So you get a relation that if your discriminant is less than 0, your function value is always greater than 0. Okay. And now there's one more thing. If there is another case, if your graph looks like this. So for this case also, if your d is less than 0, this will suffice. Here in this case, f of x is always less than 0. But what makes a graph look like this and look like this? So in both the cases, your d is less than 0, but in both the cases, the function is behaving differently, because if you calculate f of x here, it will be negative. F of x is less than 0 for all x. Okay, belonging to R. So so you will see whenever you put your coefficient of x square greater than 0, in this case the graph will be always facing upwards, and if you take a less than 0, the graph will be facing downwards. Okay, so there are many possible cases now. Imagine this is your x-axis. So for a greater than 0, I am talking about the cases. One case is this, one case is just touching over here, one case is this. Okay, and likewise for a less than 0, I'm again drawing a graph like this. Suppose there is one case like this, there is one case which is just touching, and then there is one case like this. So here we'll get alpha, we'll get beta, we'll get only alpha. Here we don't get any roots, so necessarily d is less than 0 over here. So in both the cases, over here d equal to 0, here d is greater than equal to 0. Okay, sorry, d is greater than 0 over here strictly, because you have two roots. So in this case, d is less than 0, here d is equal to 0, here is d greater than 0. Here a is greater than 0, a greater than 0, a greater than 0. Here a less than 0, a less than 0, and a less than 0. Okay, so notice this thing. So this will come very handy when you try to solve any kind of questions related to quadratic equation. So this was nature of roots. So I hope this is clear. Now we'll move